Biofriendly Podcast. It's the Biofriendly Podcast.
Well, hey, pal.
Hey, pal. How
you doing?
I'm living the dream.
You're living the dream. Good.
Yeah, how
good,
are
good,
you
good.
doing?
I am wonderful because it's cooler. It's crisper day. I've been kind of waiting for this kind of California. I feel like we jumped right into the warm weather, and I like a little cool crisp.
Crispness.
Yeah, crispness.
That's good.
Like
well,
my
it's
apples.
still technically winter.
Yeah, it's true.
Yeah. So, I mean, it should be. We'll
Guess
get a
you're
couple
right.
more crisp days before. We get some rain tomorrow.
Aren't we almost to daylight saving?
Yeah.
Isn't it? It's
Sunday.
Like it's this weekend. isn't it?
Sunday.
Sunday.
Sunday only.
Well, we do have a guest waiting in the wings.
What?
So I don't want to
Oh
make
my
him.
gosh, there he is, right
He's
there on
right
the
there. He's in the camera. For the ones who watch the show, there's just a guy sitting there watching us.
That's always
Just
a fun
hanging out.
Just
I
hanging out.
Zoom bombed you.
Just chilling. Yeah.
Yeah, I didn't even invite him. He just found the link.
Yeah, that's,
Just
hey, you know
like,
what?
hey.
However we get guests,
How's it
that's
going,
fine.
guys?
Yeah. That
Do you
works.
want some of our cold weather?
Yes.
We've got more than enough.
Where are you?
Here in the New York area. So I'm based in the New York area. I live in Connecticut. February was brutal.
Yes.
Where I live, it was below freezing all month. We had no less than a foot of snow nonstop. It's just now today, peaked at 50 degrees. And it was
Oh, my gosh.
Well, 50s can be quite lovely when
Yeah.
you're used to
I'll
used
take
to
50.
freezing. Yeah.
Yeah.
Yeah, when you're used to freezing, because we've had to work in the freezing before. If after a good couple weeks of it, when you suddenly get a 40-degree day, it's like t-shirt.
You're almost
weather.
like t-shirts
It's like
and
wearing my
shorts.
shorts.
Yeah. Well, the voice that our audience is hearing right now,
Yeah.
I'm excited.
That's your voice they're hearing right
It's
now.
not, no. They are hearing my voice now,
Yeah.
but the voice they heard moments ago was not me, and it
No.
was not you.
No.
It was our guest.
Yes.
We would like to welcome to the Biofriendly Podcast, Paul Sutter, astrophysicist,
That's me.
scientist, author, speaker, educator, man's man, baby.
Man's
He's
man.
dude, bro.
Man about town.
So he's joining us
Science
from
dude.
the East Coast, and welcome to the Biofriendly Podcast, Paul. Welcome.
Yeah, hello from the great white frozen north.
Yeah.
Yes, you guys definitely got caught up in the winter snap that hit almost the entire country.
Oh, it was nasty. There was one windstorm. We had a couple days without power. Trees are down everywhere. It's been a pretty gross winter.
Yeah. For sure. Have you lived out on the East Coast your whole life? Is that where you're born and raised?
No, actually, I just moved to the New York area about 2 years ago, and I grew up in the Midwest in Ohio. And when I moved out of there, I went down to college in Florida for a couple years, and then I came out to California, got my bachelor's in physics from the California Polytechnic State University in San Luis Obispo.
Oh, you
And
are
then
the second Cal Poly slow person. Third, actually. Yes, my brother actually went to Cal Poly San Luis
Go
Obispo.
Mustangs!
Yes,
Yeah,
that's
awesome.
I think that was our team.
Yeah, that
It was a little
that
bit
was you
busy
guys.
at the time.
Yeah.
You had things to do. You had physics to plan.
Wow.
Yeah. I had worlds to destroy, suns to
Yes.
blow up, the usual.
Absolutely.
And then I
This is
went
common.
to Illinois, the University of Illinois at Urbana-Champaign
my gosh.
for my PhD work.
That's where this
Here's
nerd
where
went.
I went to school. I went to University of Illinois.
Fighting Illini.
The Fighting Illini. I went there.
I was
for my undergrad though. So I was there from 97 to 2001 was when I went there.
got it.
Yeah.
So I was also a little bit too busy to go to football games.
Yeah, I didn't either.
PhD.
I was a theater boy, so I was over in the Cranard
nice.
Center.
Cranard Center.
Cranard Center, and the
I was
Armory,
down
doing
in
theater.
I was down on Loomis Lab.
Oh, nice. Yeah, I know where that is.
This world gets
It's
tinier
down on
every
Green Street.
podcast.
It's just one of those artifacts from the Cold War.
Yeah.
It was not a pretty building.
Before we dive into subject, I just have to ask because I don't even know if it's still there anymore. But my hangout when I was at U of I was Murphy's Pub, and it was around on Green Street until I left. Was it still there when you went there?
Yeah, Murphy's Pub. Would they do the Irish nachos where they give you waffle fries and then load it down? Yeah, that's a Saturday night treat.
Yeah, absolutely. Cool. I love
Very
these worlds
specific audience.
colliding.
That's so fantastic.
But we don't have to sit here and reminisce about our college towns.
Back in my day.
The audience wants to know about space, Jacob.
That's true. Well, we normally on the Biofriendly Podcast, this is a unique guest because we normally keep everything on the ground. We normally keep everything right here on planet Earth. But
Yes.
today we have an astrophysicist. We have a guy who deals with space. So
Yeah.
we're leaving. We're leaving Earth.
We're getting out of the
We're
planet.
done with this place.
Getting the heck out of Dodge, and we're going up into space, and we're going to hear about what led Paul into this world that you work in, or out of this world that you work in.
Why space? Why astrophysics?
Yeah.
That's actually a really fun question, because I distinctly remember growing up not having a time in life when I wasn't interested in all sorts of science. So I was reading about biology. I was reading about dinosaurs. I was reading about chemistry. I was reading about physics and astronomy. I just remember voraciously absorbing every book my parents would get me as I grew up. But I never realized as a middle schooler, as a teenager, when I was picking a college, I never realized that being a scientist was like something that I could do.
Right.
I swear, I always assumed that scientists were smarter than me. And yes, I can read these books and I can enjoy it, but like, I'm not going to actually do it.
Yeah.
So I was a total computer nerd. So I went into computer programming. That's why I went down to Florida, Embry-Riddle Aeronautical University.
Okay.
Wasn't feeling it there. So I transferred to Cal Poly again as a computer science major. I was in my third year of college and I took an elective in astronomy and fell in love with it. Got to understand the math behind the science for the first time. And it's such a different experience to understand the science from just a lay perspective or like a popular science perspective, and then understand the science from a mathematical perspective. Yeah. And I started to just absorb it and want to learn more. And I would talk with the professor all the time. And then one time he said, like, you know, Paul, you can be a scientist if you want to.
Nobody's stopping you.
Nobody's stopping. But it is right. It's like on a pedestal, right? It's one of those things that it's put on a pedestal.
Well, and I was like, no. And he's like, yeah. And I'm like, no. And he's like, sure. Like, try it. Like, switch majors. And in less than a week, I switched majors to physics. And I never looked back. And then when it came and I had no plan, I had no idea what I was doing. I just switched majors to physics. It was the physics classes I took were like the hardest classes I had ever taken.
Yeah, of course.
Of course. Nasty. I was like tears after exams. And, but I felt like I was finally being challenged. I was finally growing and learning something new. Eventually I decided to go into grad school. I went into grad school, got accepted by Illinois, and got to pick where I wanted to go. Like, did I want to go into astrophysics or cosmology? Did I want to go into high energy particle physics? Did I want to study string theory? Did I want to study chaos theory? You know, like there's, it's a very large, very well respected department. So there are lots of top flight people there to study under. And after a few conversations with a few potential advisors, I rekindled that love of space that I always had and went into astrophysics. So my PhD's in physics, but I specialized in cosmology, large scale structure of the universe, astrophysics systems, went on to do, again, with no plan, like I went into grad school, like I'll give this a shot. Got my PhD, then spent 3 years at the Paris Institute of Astrophysics in France, and then 2 years in the Trieste Observatory in Italy, back to Columbus, Ohio, near where I grew up, where I had a position at the Ohio State University, and then also as the chief scientist at the Science Center there. Started really growing my outreach and communication, found a love and passion for that. And 2 years ago, like I mentioned, moved to the New York area. And I still maintain some research lines, but most of my life now is dedicated to writing books and hosting TV shows and sitting behind this microphone way too much.
Yes.
Yeah.
Totally. Getting the word out about space and why it's rad.
It is rad. And, you know, you mentioned nasty physics, and I thought if there was a class called nasty physics, I would have enrolled. Like all they need to do to lure people in is just some kind of racy titles, you know, like come take nasty physics.
I feel like if you went to a nasty physics class, you'd spend the whole time dancing.
Oh yeah, I would. Yeah. I would definitely. They would
you'd be like, is that not what this is?
Mr. Gibbons, I'm going to need you to sit down. This is not a dance class.
Yeah.
No, that sounds amazing. So now you do the hosting thing, the educating thing, and you kind of help people access and understand this, you know, this thing of science that seems so far away, but it's something you've been able to pursue.
I try to communicate, especially to kids, that like, guess what? You can be a scientist too.
Yeah.
That's awesome.
That's great.
You're in luck.
It is,
This show is listened to by kids. They love it.
Lots of them.
Hi,
yeah,
kids.
Lots of them. Yeah. Hi, kids.
Yeah, kids love it
Outside
because
there
because
are
we
no
keep it
jobs,
fun.
but that's a different show.
You can be a scientist. There's no work, but you can be a scientist.
You can still be assigned.
Follow your dreams.
That's great. So, all right, we're an environmental show, so we'll probably kick it off with just a basic starting question, which is there okay? How would you relate what we're doing to our environment, and how that affects? How can we be affected by what we're doing in the environment in terms of like space? Like one thing I've been hearing about it. I saw a YouTube video, so it's obviously a quality source.
Right.
But basically,
yeah.
the poles are moving at like 23. The magnetic poles are moving like 23 miles a year or something like that, and that there's evidence that they're starting to flip, and that we may have more than one magnetic pole at a time for a while, and that has an effect on us and our how we resist the sun and things like that. Is that a thing?
Is that accurate? Or is that conspiracy YouTube stuff? Yeah.
Yeah, exactly. What channel was this? No.
Yeah. It's
No.
Bob's.
The basic gist is right. And that's a helpful way to think about the fact that the Earth is not an isolated system. It's not just our oceans and our atmosphere and our biomes and our human activity. There's a lot going on, both inside the Earth and outside the Earth, that affect us, that affect our climate, that affect our seasons, that affect our weather. One of those, like you mentioned, is our magnetic field, which is generated in the molten core of the Earth. It's a spinning ball of molten iron. And so it generates this super strong magnetic field, one of the strongest magnetic fields in the solar system.
Nice.
But because it's a spinning ball of molten iron, it's not exactly stable, and it like folds in on itself, and there'll be turbulence, and it will shut off and come back on. It will reverse. Our north magnetic pole is scooting across northern Canada as we speak. It's been doing this for a while. We think that every few 10,000 years, our magnetic field shuts off and then reappears with its poles reversed. This is a very common thing. The magnetic field of the Earth does protect us and our atmosphere against a few things. It protects against the solar wind, which is this stream of charged particles constantly emanating from the sun. It's just blowing through the solar system. Right. And the solar wind hits our magnetic field, gets wound up by our magnetic field lines, and gets dumped into the poles. And that's what gives us our northern and southern lights, the aurorae. But then there are also like high energy cosmic rays that are blasted out by like supernova going off millions of years ago that are just now entering the solar system. And our magnetic field is one of the things that helps protects us against that deadly form of radiation.
Sure.
Yeah. Wow. So solar winds are different than summer winds, like when Frank Sinatra sings about, summer winds coming in. So it's different. These aren't the same thing.
Yeah, the first version was about solar winds, but
wasn't it?
They decided to edit it in post. So
solar winds come sweeping in. So
yeah, that's good. Yeah, that's fascinating.
That's fascinating.
So what else? So like the magnetic. So if that does disappear for a while, do we have other defense against just from our atmosphere, or are we just
sunblock?
More sunblock,
pretty much.
Sunblock 3000. Yeah.
The good news is that the magnetic field changes over the scale of thousands of years. So we don't have to worry about it right now. And even if it's shut off, we still have other defense mechanisms against cosmic rays, like our thick atmosphere absorbs a lot of those cosmic rays. So we'll be okay. I'm not too worried about our magnetic field.
That's right.
Like sometimes our sun, here's a cool fact, like our sun steadily gets brighter and hotter as it ages. So the dinosaurs knew a colder, smaller sun than we know today. And in fact, in as little as a few 100 million years, our sun is going to be too hot. It's going to evaporate our atmosphere and boil our oceans away. So Good night, kids.
Wow, just a couple 100 million years
how about
away. That'll be like we gotta keep our eyes
be there
open.
before
It's
we
like
know
tomorrow.
It is. I mean, on a cosmic scale, right? That's no time at all.
Essentially, yeah. We are in the last like major epoch for the possibility of life on Earth.
Well, I feel like in all the
Wow.
dinosaur movies, they really blew the whole like sunlight thing. It should have always been kind of more low light, kind of candlelit
little
scenes.
more romantic, you
Yeah,
think?
like that kind of look.
Yeah.
It was a dimmer sun.
No,
That's all I'm saying.
I hear you. Although, okay, but here's an interesting thing though. But it was hotter back then on the planet when the dinosaurs were around than it is now, just because of how the atmosphere is, which is something that's relatable to our topic. And something we hear a lot is you don't, and this is obviously an exaggeration, or I think it is, but you don't want to turn Earth into Venus because Venus is an example of the greenhouse effect gone crazy. Does that?
Oh, yeah.
I mean, that's yeah. So you want to kind of explaining that a little bit for our fans with how Venus kind of is the greenhouse effect? gone crazy?
Venus is hell. Yeah. And here's the thing.
Great album name, by the way.
Yeah. Venus used to be awesome.
Yeah.
Billions of years ago, we're pretty sure that Venus had liquid water oceans. It had a relatively thin atmosphere. It had like white fluffy clouds and like little bunnies hopping around. It was a great place.
Yeah.
But as the sun got steadily brighter, it got too hot for Venus. And that's exactly what we're worried about happening with the Earth. If we increase our greenhouse emissions beyond a certain critical threshold, what happened to Venus was that things got a little bit warm. So the oceans started to evaporate. And that put more water vapor in the atmosphere. Right. That water vapor in the atmosphere was a greenhouse gas, so trapped more heat, which evaporated more oceans, which trapped more heat, which evaporated more oceans. Soon enough, all the oceans dried up. All that water is up in the atmosphere. Wow. And without that lubrication, we think that Venus used to have plate tectonics, but then it shut down.
Right.
And plate tectonics play a critical role in pulling carbon out of the atmosphere, where the carbon binds to like silicates and rocks and stuff. And then it goes down into the mantle and then helps sequester that carbon. But without the plate tectonics, the carbon just hangs out in the atmosphere. Volcanoes are going, carbon is leaking out of rocks and so the carbon dioxide in the atmosphere of Venus begins to build and build and build. And then you fast forward 100 million years, you end up with a planet with an atmosphere that has a pressure 100 times greater than the Earth. You have a planet with surface temperatures greater than 800 degrees Fahrenheit. That is hot enough to melt lead. In fact, it's the hottest surface temperature in the solar system, even though Mercury is even closer to the sun than Venus. And it's just this horrible, horrible world. And so with our human greenhouse emissions, I'm not exactly worried about us turning into a Venus, but it's the exact same physics of we're worried about these kinds of positive feedback loops that lead to more greenhouse gases, that lead to more warming, that lead to more greenhouse gases, and it becomes very, very difficult to stop.
Wow. That's cool.
Yeah, that's wild.
I am learning so much right now. I'm you know what I mean? It's like, I love the way you put it, man.
Yeah,
this is
awesome.
great. This is great.
And then we're near JPL here, and someone from JPL once told us that the fun things about the difference between landing something on Venus and landing something on Mars is on Mars it's I think like 5 or 10 minutes of insanity, terror, 10 minutes of terror, but Venus is 2 hours of boredom or something, like, because it's like the atmosphere is
such a thick atmosphere.
Yes, it's like it's like hand sanitizer
into Venus at orbital velocity, and that like just your drag from your body will make you land safely on there. Now you'll melt because of the extreme temperatures. And also, did I mention that the atmosphere has tons of sulfuric acid? Acid, right? So you'll
which is
dissolve
lovely this
and
time
you'll
of year.
melt.
You'll dissolve and
Like,
melt. It's not great for you, but
technically, like parts of you will land.
Right.
Yeah. So my atomized form or whatever, we'll get there eventually. Yeah.
Exactly.
Yeah.
Wonderful. So, okay, but before we leave Venus and go elsewhere, is there any conceivable way to start a reaction that would reverse it and make it livable again? Or is it just... hopeless.
There have been a few proposals, especially back in the day before we really knew a lot about Venus's atmosphere.
Yeah.
But if you wanted to make Venus hospitable, you need to get rid of the atmosphere. You need to sequester as much carbon as possible. You need to pull that carbon dioxide out of the atmosphere. So if you can, say, seed the atmosphere with something that binds to carbon dioxide and makes it heavy and rain down to the surface, that might do the trick.
Right.
But what's interesting about Venus and why some people still talk about it is that as you go higher up in the atmosphere, the temperatures get lower and lower and lower.
Yeah.
And there's a band in the atmosphere. I forget the exact height. It might be like 20 kilometers up, where the temperatures are like room temperature. And the atmospheric pressure is like Earth's atmospheric pressure.
Interesting.
I mean, it's still carbon dioxide and sulfuric acid, like nonstop.
There's that problem.
Like it's still horrible,
Yeah.
but it's like slightly less horrible than the surface. So if you were to want to live on Venus, you're going to need like the Lando Calrissian Cloud City.
Yeah.
on it.
That's interesting.
Yeah, that's what we need.
That'd be kind of fascinating.
Just do that. Hey, NASA.
Yeah, NASA, build the Cloud City. I'm actually really stoked that we're starting on Venus because I feel like Venus is not getting the press anymore. Like Mars is hogging the spotlight.
Right.
You know what I mean?
Mars
Like
always
you guys
hogs
are
the
shining the light on Venus and everybody's talking about Mars. Wait, what did he say?
Mars always hogs the spotlight.
Totally does.
Mars.
Yeah. Well, everybody thinks. See, Mars, by contrast, right, is that planet that everyone thinks, well, if we can just do a couple things, we can actually terraform it. We can turn it into someplace livable. And
We can plant potatoes out of our poop. Yeah.
Right.
Yeah,
poop potatoes.
the problem is you can't.
Really?
Yeah, it stinks.
Oh, here we go.
So
bring the heat, Paul.
I wish I could to terraform Mars, but I can't.
Yeah.
No. What you need to do. So Mars, the problem with Mars is the reverse of Venus. We also think Mars used to have liquid water oceans, a decent thick atmosphere, warm temperatures. But what happened was Mars is that its core cooled off and its magnetic field shut down. And then the solar wind blew away its atmosphere. And then the whole place dried up.
Yeah.
Wow.
Current Martian atmosphere, again, carbon dioxide, the universe really likes carbon dioxide, is less than 1% of the air pressure of the Earth. So in order to terraform Mars and in order to make it more interesting and Earth-like, you have to warm it up. You have to increase the air temperature and you have to increase the atmospheric pressure, use that increased pressure to warm up the planet. You need to do this whole greenhouse cycle again, this time on purpose to warm up Mars.
Wow.
If you look around on the Martian surface, like, hey, is there any carbon that we can dump in the atmosphere? Is there any water that we can turn into vapor? There's a lot. The northern and southern polar ice caps of Mars are made of frozen water and frozen carbon dioxide. There's a bunch of carbon locked up in the rocks of Mars, some of it frozen, some of it chemically bound. The problem is that if you were to release every molecule of carbon dioxide, every molecule of H2O into the atmosphere, you are only going to roughly double the air pressure. So instead of being 1% of the Earth's 2% air pressure, it's going to be 2%.
Wow.
That will give you around a 10-degree warming, which is not much, considering that the average temperature is like negative 80.
Right.
Yeah.
You're going to get to negative 70 for all your work. That is not enough to go out on the surface totally exposed. If you're exposed on the Martian surface, it's like vacuum. All your sweat and oils instantly boil away and evaporates and cause skin damage, and it's pretty miserable. Like, there just isn't enough stuff on Mars in order to build that thick atmosphere. So you have to import it from somewhere else. You have to crash comets on it.
So you have this large comet crashing freeway basically in order to pull it off.
You need trains of comets that are crashing in. They release their ammonia. Comets have a lot of ammonia in them. The ammonia itself acts as a greenhouse gas, traps some heat. Then ultraviolet radiation from the sun hits the ammonia, disassociates it into nitrogen, which is a nice thing to make an atmosphere out of.
Yeah.
Sure.
So we just have to develop the technology to haul in comets from the outer solar system and crash them on Mars.
No
So
big
biggie.
deal.
Armageddon.
No big yeah.
Bruce Willis.
Bruce Willis.
You get them. You get a bunch of oil rig drilling guys, and you throw them on a comet, and
Yeah.
that we know that works.
We've proven it.
and we don't
I
want to
saw
miss
the
a thing.
documentary.
You saw the documentary.
You saw the documentary,
Yeah.
right?
So now ammonia, that's what Windex is made of, right?
Yeah.
So we'll have a cleaner Mars too.
Okay.
At the same time.
This is great.
Yeah.
This is gonna work.
This is gonna work.
This is gonna
We're
work.
get Bruce Willis,
Bruce
with his
Willis.
Windex, and we're
sure
gonna
he'll
crash a bunch
volunteer.
of comets. Yeah, this
Yeah.
is good. This is no problem. Wow. So there. Okay. Well, one of the things I was gonna ask is, do you think there's any danger of we've already, we're doing what we are with this planet. Yeah. Is there? Part of me wonders, should we be messing around on other planets until we've figured out how to take care of this one?
I mean, that's a very valid argument. Like, there's always going to be arguments against space travel,
Right.
because it's expensive, it's hard, the payoffs aren't immediate and obvious. Meanwhile, we have like kids starving and social justice issues to take care of, and the environment and climate change. Overall, though, the amount of money that we spend on fundamental research, on NASA, on space exploration is pocket change.
Yeah.
There was a year during the height of the Second Iraq War where we spent more money on air conditioners for tents than we did on NASA.
Wow.
The first round of the COVID relief bill, the one passed last year,
Yeah.
we spent more money in that one relief package than NASA has ever gotten in its entire history.
Holy smokes.
crazy.
So we really don't spend a lot of money on NASA. So when people say, if we cancel NASA, your taxes would be exactly the same.
Right.
change
We're
nothing.
not,
Right.
you're not, this is like a rounding error on the federal budgets. Like 0.5% of the federal budget goes to NASA. And through NASA, we fund like all of our space activities. And then, as we've been seeing and watching with delight over the past 10 to 20 years, private companies are starting to up their game with space. Like we have SpaceX, we have Blue Origins, we have Virgin Orbit. We have all these companies that are using their private money,
Which is so cool.
and the money of investors to launch rockets, to build reusable rockets, to like want to go to Mars. And then it's like, I don't want anyone judging me on how I spend money.
Right.
I don't want people judging me on how much cheese I buy. It's not your business. So like if a bunch of super rich people want to build some rockets to Mars, more power to you.
Yeah.
Why stop them?
Yeah.
Well, and there's also, I mean, I'm glad you answered that way because I love the idea of space travel. I'm a Star Trek nerd and
Me
Star Wars
too.
nerd.
I want to go. I want to go. Right.
Getting out. Well, I also think that
I do.
the more we do that, the more we'll learn. Right. If we ever did get into a position where we're forced to have to terraform something else, we better know how to operate in space, or we're just forget about it. We're done. I mean, we've only got 100 million years, and the sun's going to be too hot.
Right. It's going to be too hot.
We got to figure out how to get
Clock's
off.
ticking, folks.
Yeah. So we get to that. All right, cool. Okay, so all right, just because I love this topic so much. So let's go a little farther out into the solar system. And let's start looking at the moons of Jupiter and Saturn, right? Aren't there some pretty fun moons that show some possibility of at least being able to park there for a second?
Oh, yeah. So the moons of the giant planets are the like ultimate surprise just package that nobody realized would ever be interesting. So let's take a look and say Europa. Europa is the second largest moon of Jupiter. Okay. And you look at its surface and you're like, whatever, it's a bunch of ice, frozen water ice. Yeah. It's got a bunch of cracks and fissures and like, it looks pretty cool. Like if I were to show you a picture of it, you're like, that's nice. Yeah. But it's also pretty boring.
Right.
But Europa and a lot of moons out there in the outer solar system have a secret. Okay. And the secret is that buried underneath that ice, this shell of ice, there is a globe-spanning liquid water ocean.
What?
And not just a little bit of water. We think the ocean on Europa is up to 100 miles thick.
Wow.
There is more liquid water on Europa than there is on the Earth.
That's outstanding.
That just blew my mind. That's insane.
And Europa's not alone. Callisto might have a liquid water ocean. Enceladus might have a liquid water ocean. Titan might have a liquid water ocean. Triton might have a liquid water ocean. Even Pluto might have a liquid water ocean underneath its crust.
That is wild. That's amazing.
That is absolutely amazing.
And where there's liquid water, there's the potential for life.
That's what I was going to say. If you can drill down deep enough and get into it, you might be able to find something.
Yeah, it's just 100 miles of rock hard ice.
You know who could drill?
Willis.
Bruce Willis.
He's really great.
Bruce Willis and the guys.
Comes back to Bruce Willis. What can't that guy do?
They're already on a comet. What you do is you get him.
You send Bruce Willis a comet. You drop him off on Europa so he can drill the hole, and then you pick him back up on your way back into the solar system.
I have a disastrous idea for the solar system if you're an environmentalist.
Okay.
Are you ready for it?
Let's hear it.
It's
There's
terrible.
nothing like a green podcast that tells you the worst idea.
This is the worst thing we could do.
Good.
Here's what we do.
Okay.
So we put some kind of sail on Europa.
Yeah.
And then we throw it out of orbit of Jupiter.
Yeah.
And then we push that sucker and we crash it into Mars and get all of that liquid water.
Wow.
It's a great idea. What you need,
and then we terraform Mars.
is you need Bruce Willis.
Yes, and a nuclear bomb.
This is a good Hollywood script, I gotta say.
I'm sorry. We sometimes will go a little bit too far on these things. But yes.
No, it's fine. We don't know if there's life on Europa, but like if you're ranking the places where life might appear in our solar system, the icy moons of the giant worlds are at the top of the list.
So now, how cold are those though? They're probably pretty chilly.
Pretty Arctic, yeah.
Well, the surfaces are below freezing, incredibly, incredibly cold. We're talking like negative 200, negative 300 degrees.
Okay.
But the interiors, the very cores are hot. And that's because as these moons orbit the giant planets, they orbit in these big elliptical paths. And so they get stretched and squeezed from tidal action from those giant planets. And this heats up the core. So the core of Europa is molten. And then the surface is freezing cold. And in the liquid water ocean, it's warm enough for liquid water.
Right. It's gotta be water temperature.
All right.
Wow. So
grab your swimsuit.
That's
head to Europa.
it. That's where we'll all turn into mer
Europa,
people.
That's it.
We'll turn into mer
Great
people.
ice
and live
fishing.
There.
Yeah, great ice fishing. What are some of the things that you've learned in your years in this line of work that you think more people should know about our solar system, about space, or a planet in particular? Things that you tell a group of people or crowd, and they literally. I mean, you've already told several things on the show that I'm like, my mind is blown. But I wanted to know if there were any other kind of unsung heroes or things about our galaxy that are cool to mention.
Yeah, I think one of the threads that I've always clung on to as my career as a scientist and as a science communicator, one of the things that always draws me and fascinates me about the universe is the true universality of what we're doing. When I write down an equation or develop some law of physics, that law of physics or that understanding applies throughout the universe, through all space and time. Right. And so if we understand how, say, a hydrogen atom works here in a laboratory on the Earth, well, then we know how a hydrogen atom works on the other side of the galaxy. Right. We can apply that knowledge. We can extend our understanding, our consciousness to encompass the entire universe. We can write down equations on a chalkboard that summarize and accurately model and predict the entire history of the universe over 13.8 billion years. Like, how did we get to be able to do that?
Right?
How cool is that?
It is so cool.
That we can grapple with these kinds of scales in both space and time and come to terms with them and make predictions and measurements and observations. Just that universality of science is something that I absolutely love about cosmology, about astrophysics, about physics and science itself, and something that I try to communicate in everything I do.
Yeah.
That's terrific.
That's exactly what I was looking for. Because I am literally over here just going, I'm Keanu Reevesing so hard. I'm just, whoa. I'm just like.
Oh, so you're not walking out with a gun?
No. I'm not John Wick.
Different Keanu.
Different
This
Keanu.
this is more like early 90s Keanu.
Yeah, this is
Keanu.
90s Keanu, not modern John Wick Keanu.
Yeah, although I do love modern John Wick.
I do.
Keanu a lot. He's a lot of fun.
Really fun. It's really good.
Just don't hurt his dog.
Don't hurt his
mess
dog.
with his dog,
No.
or he'll put a book in your face and keep punching it.
Exactly.
He'll just keep punching it.
For starters.
Yes.
But anyway, I wanted, okay, so you obviously, I wanted to pass it back to you if you had any other questions, because we have already kept Paul here for a little bit, so we need to start wrapping things up. But
okay, well, we'll speed through. I'll go back to, all right, well, I'm going to go back to the sun now. I keep flying back and forth. Okay. All right, so solar flares. A friend of ours, another incredibly reliable source, said that like something around the 1800s, there was a solar flare that would have taken out the entire power grid, but at the time it didn't matter because we didn't have one. What is that? Is that true? And if that's true, what is the likelihood of something like that happening again? And what can we do about that?
Yeah, so what your very reliable friend is referencing, and I know it's just by your friend, you mean yourself. You looked this up.
This is me. I looked it up, and I'm tuning you from very exactly.
I believe the year was 1856, but I could get the year wrong. There was a massive solar flare. Astronomers around the world knows the sun got super, super bright, and shortly thereafter, telegraph operators were getting shocked, like literally electrically shocked.
Wow.
And there was a measurement by John Carrington who put all the pieces together. And so we call it the Carrington event in his honor, who realized that when the sun flared, it sent out what's called a coronal mass ejection, which is a giant vomitous ball of sun plasma that races through the solar system, and it hit the Earth and dumped all of its electromagnetic energy on the Earth. Yeah. If it happened today, I don't know if it would overwhelm our electrical systems. That's a little bit tricky to say.
Yeah.
But it was by far the most powerful electromagnetic storm ever recorded. Presumably, this has happened for millennia, but we didn't exactly have electrical systems to be able to see this.
Right.
Yeah.
But then, like a few years after we developed the telegraph, we're starting getting shocked. There has not been anything that strong since. And in fact, for the past 100 years, the activity on the sunspot activity, the flare activity, the coronal mass ejection activity, all of it has been steadily getting weaker and weaker for the past 100 years. We have no idea why.
Interesting. So less and less. So it's becoming less likely.
Exactly.
For now.
But you know what? The sun tomorrow could decide, tomorrow's a new day. The sun could be like, I'm back.
Yeah,
I'm back, baby.
Hold my beer.
Ball of fire. That's crazy.
Wow, that's fascinating. Okay, all right, last one.
I love it. I love it. I wish I could talk to Paul forever because this is one of my favorite subjects in the world.
That's the thing. I feel like I hope we're asking decent questions. Our audience will. You know what we'll do?
We're not
We're going to
asking
have to
decent
have you
questions.
back, and then next time our audience will yell at us and say, "Here's what you didn't ask, you jerks."
Yeah.
Next time, ask, and then we'll try it all again. We'll try it all again.
Yeah. Now he's a friend of the Biofriendly Podcast.
That's right. It's
So
official.
you're
Once
stuck.
you're in, you have no choice whether you want to be friends
Is that
with us
a
or
good
not.
thing or a bad thing?
Both.
It's
both. It's a mixed bag. It's a real mixed bag
Yeah.
because you're stuck with
That's fair.
Noel and I. So
Yeah, that's the downside. The upside is the world will love you.
yes,
Yeah,
absolutely,
that's absolutely the upside. Yeah.
Go ahead with your question.
Okay, so all right, in terms of traveling out of the solar system, you've got to go. Here's the thing that the distance has always blown me away, right? Like it's just to get out to Pluto takes a very, very, very long time.
Forever, man.
Forever, right?
Yeah.
And then to get to the closest star, we're talking 4 light years.
Right.
We don't really go that fast. We don't go even close to that speed.
No.
So do you think there's ever are we ever going to figure that out? Get to the point where we actually will be able to send something or someone out to the next closest solar system that's that far away? No.
No.
Yeah.
No. We're stuck.
Yeah.
We're
It's
stuck.
just that
Interstellar
far.
travel is tough. It's tough.
Yeah.
The Voyager probes, New Horizons, all the probes that are on escape trajectories, if they were aimed at the next nearest star, Alpha Centauri, and they're not, But if they were, it would take them like 40,000 years to reach there.
Yeah.
Wow.
There have been proposals. There's this light sail star shot initiative idea.
Yeah.
Some Russian millionaires pouring a bunch of money into this. Yeah. The idea is to develop and build a kilometer-wide solar sail, highly reflective sail, put it out in space, then build the world's most powerful laser.
Yeah.
Which would require the entire energy output of every nuclear reactor in the United States.
Okay.
Operating for 15 minutes solid, which is approximately a trillion times longer than our most powerful lasers are capable of.
Okay.
Shoot it at that. Shoot it at it for 10 to 15 minutes. It would accelerate that spacecraft to a tenth of the speed of light, and it would reach the Alpha Centauri system on a flyby in about 40 to 50 years. In order to do that, if you have that amount of energy, that amount of lasers, and you can actually build the thing and shoot the laser, and nothing blows up, and no one takes over the world with it.
Right.
And then you have your giant 1 kilometer solar sail, and it's almost perfectly reflective, so it doesn't melt when the giant laser shoots at it. Right. In order to do that, your spacecraft has to weigh no more than a paperclip.
Wow.
So in 100 years, we might be able to send paperclips to other stars.
How exciting will that be when they get the paperclip, though, when it lands?
When they finally we did
it.
What is this?
What is this thing?
What about the Wrinkle in Time idea of folding space and things like that? Is this ridiculous?
It's like
the pause.
Yeah, he's like, well, it's a book. It's a science fiction book by Madeline Lingle.
Yeah, that's the one. That's the one. Okay, so we're here for a while at least until we get better ideas as to
enjoy while it lasts, folks.
Yeah.
Got about 100 million years.
100 million years.
The sun's gonna get too hot.
Yeah.
Unless we get Bruce Willis to crash Europa into Mars.
Mars, and then it's on.
If you could get Bruce Willis onto a paperclip and set him on, then maybe we'll be able to
a paperclip-sized Bruce Willis.
Oh, paperclip-sized.
The problem is Bruce Willis is too big.
Willis.
Yeah.
We're going to go into...
We'll upload his consciousness to a paperclip.
We're going to go to Universal Studios and pitch this. We're going to say we get a paperclip-sized Bruce Willis.
Yeah.
We send him in his space.
That is wonderful.
Sold.
Thank
Soundtrack
you
by Kenny Loggins.
so much for coming in here and talking nonsense with us. We really appreciate it.
This was so much fun. Thank you again for having me.
Yeah, absolutely.
For sure.
And this is the point of the show where we do our tags. We close out. We always give our guests the opportunity to stick around.
That's right. We have tags.
We have tags at the end of the show. So you can stick around or you can bail. It's whatever you want to do. We just kind of close out the show with our tags.
All right. Unfortunately, I do need to go.
He's got to go.
No worries. We get it.
You know what? You'll remember us more fondly this way.
Fair.
All right, Paul Sutter, pmsutter.com. Check him out. He's got a lot of great videos and books out there that you can read. He's a very smart dude. We're so honored that you came on the show today. So thanks for joining us. We'd love to have you back. And all the best to you out there in outer space.
In Spaceland. Yeah, Spaceland. Good luck on Earth, folks.
Thank you.
All right. We'll see you, Paul. Take care. Bye. Well, that was one of the coolest guests we've ever had. One of the coolest. Not to slight all the other awesome guests we've had. We've had amazing guests.
You said
one of.
For all, you could be talking about all of them at once.
Yeah, you're right.
Because they all are one of.
Thank you for saving my butt.
Yeah, you got it. He was terrific, though.
Terrific.
That was fun.
I mean, look, I could talk about space and space travel and planets all day. And I learned a ton.
I love how blunt he was, too.
It's he was.
So can we get to Alpha Centauri? No, you can't.
No.
It's not going to happen. Even if we build the super laser that's every single nuclear power plant all of them.
I think it's
pointed at a sail that has to somehow reflect all of that energy. You could move a paperclip.
Sometimes you just need that level of honesty, right?
Yeah.
Like you need to just be like, look, I think that would be great if we could get there, but I don't think we're going to be able to get there.
Yeah.
Until somebody figures something out.
Well, we're going to have to improve the way we're thinking about it. Obviously, that's what that tells me. It's that we're not mentally even close enough to the idea. But you know what? That's okay.
That's okay.
Good times.
This episode was sponsored by the Travel Bureau for Venus, reminding you that I'm your Venus, I'm your fire, I'm your desire.
Yes.
But we are your beacon of light in a gloomy environment.
Carefully avoiding neonicotinoids.
We are the Siegfried and Roy of podcasts. I'm laughing because the next one is this show is
This show is garbage.
this show is garbage.
This show is no, it's not. This
It's
show's
something
garbage.
like
It's
that. It
this
was like a joke.
This show is a
This
joke.
show's a
This show
joke.
is a joke.
It has to be said with so much disdain,
Yeah,
right?
yeah,
Like,
yeah.
This show's a joke.
I like that we said garbage. It's like this show is garbage.
It's perfect. It's perfect. Well,
All
that's it.
right.
Cheerio.
It's the Biofriendly Podcast. It's the Biofriendly Podcast.